welcome to Cambridge Chemistry by Sarvat Ahmed. Today I will solve Feb March 2023 paper 2-2. Let's start. The following electronegativity values of elements can be used to predict the chemical properties of compound. Use the information in table. Answer the following question. Define electronegativity. Electronegativity is electronegativity is the power of an atom to attract electrons to itself. Oxygen and sulfur are in group 16. Explain the difference in Pauling electronegativity values of oxygen and sulfur. Oxygen and sulfur. Explain the difference in the Pauling electronegativity values of oxygen and sulfur. Oxygen has 3.5 while sulfur is 2.6. Sulfur has lower electronegativity value than oxygen due to oxygen has lower nuclear charge due to one less shell than sulfur. So there is greater attraction for nucleus in oxygen. Lithium hydride is an ionic compound. Draw dot and cross diagram of lithium hydride. Lithium include all electrons. This is lithium. And this is hydride. Negative ions. Suggest the shape of the molecule of H2S. Non-linear. Because sulfur, this is sulfur, this is hydrogen, this is hydrogen. Sulfur. Write an equation that represents the first ionization energy of hydrogen. Gaseous electron is removed from gaseous 1 mole of gaseous atom to form 1 mole of gaseous ion. Electron. Explain why there is no information given in table for the second ionization energy of H. Hydrogen cannot undergo second ionization energy because it has only one electron. Give the full electronic configuration of S2 positive. One S2, two S2, 2p6, 3s2, and 3p. Sulfur. Sulfur is 16. Sulfur atomic number is 16. So sulfur has 16. So 2 positive, then 1s2, 2s2, 2p6, and 3s2, 3p2. 1 less electron from the 16. Carbon dioxide and sulfur dioxide are acetic acids. Write an equation for the reaction of sulfur dioxide and water. SO2 plus water, H2SO3. Write an equation for the reaction of sulfur dioxide with sodium hydroxide. SO2 plus sodium hydroxide to form Na2SO3 plus water. Construct an equation for the reaction of carbon dioxide and magnesium hydroxide. CO2 plus MgOH twice to form MgCO3 plus water. Complete table 1.2 by picking a tick to show which of the compound have molecules with an overall dipole moment. 1e. SO2 Complete table 1.2 by placing a tick to show which of the compounds have molecules with an overall dipole moment. Overall dipole moment. This has no dipole. Cancel the effect of each other, and this has dipole because sulfur has electron. This is the structure of sulfur dioxide. So it has dipole moment. So again this is the same. So cancel the effect of no dipole moment, and this is different case. Sulfur, carbon, sulfur. Oxygen. So there is a difference between the electronegativity values. Over here 3.5 for oxygen and 2.6 for sulfur. So, and this is 2.5, this is 3.5, and this is 2.6. This difference is 1 and this difference is 0.1. So there is a difference in electronegativity value. So this compound also has a dipole moment. At 150 degrees centigrade, 103 kilopascal of compounds listed in table 1.2 are gases. Under these conditions, 0.284 gram of one of the compounds occupies a volume of 127 centimeter cube. Use the information to calculate MR of the compound, hence identify the compounds from these given in table 1.2. Show P by using general gas equation. PV is equal to nRT and MR is equal to M over sorry PV is equal to M over MR RT and MR is equal to M in RT over PV. So by applying values, MR is equal to 0.284 gram mass into R, general gas equation, gas constant 8.314 into 127 degrees centimeter cube is the volume, and temperature is 150 degrees centigrade. So 150 plus 273 is equal to 3 5 7 12 150 plus 273 is equal to 423. Divided by 103 kilopascal, so this is pascal into 10 raised power to 3 into 127 centimeter cube, mean 127 into 10 raised power to minus 6. So MR is equal to 76, round about 76. Table and use identify the compound from those given in table 2. Carbon dioxide is 44, mass is 44, SO2 30 64 32 plus 32, this is 64, CS2 12 plus 64, 4 to the 6 and 76. So this is CS2. Next question is, the group 2 elements magnesium to barium are all silvery white reactive metals. Draw a label diagram to show the bonding and structure of the group 2 metals at room temperature and pressure. Delocalized electrons, and this is positive ions. Magnesium has more delocalized electrons than sodium. Write an equation for the reaction of magnesium with cold water. Magnesium plus water to form magnesium hydroxide plus H2 gas. Identify a single reagent that can be used to distinguish separate samples of dilute magnesium nitrate and dilute barium nitrate aqueous. By using reagent, single reagent is sodium sulfate Na2SO4 and barium sulfate. Identify single agent that can be used to distinguish. Add sodium sulfate in both solutions. Barium sulfate is insoluble while magnesium sulfate become soluble. You can add sulfuric acid as well. Describe what is observed when strontium iodide react with concentrated sulfuric acid. What is observed? Strontium iodide. So this is the reaction with sulfuric acid. The reaction is strontium iodide plus H2SO4, strontium HSO4 plus HI, and HI further react with H2SO4 to form this reaction iodine plus sulfur dioxide plus water. So the observations will be 2H2. Observations reacts with concentrated sulfuric acid. Purple vapors of iodine and and sulfur dioxide gas. So it can be purple vapors of iodine, and there is another reaction of sulfur dioxide and all possible products. If we see all possible products of when hydrogen iodide is oxidized by sulfuric acid, so there is sulfur deposit as well, sulfur dioxide and H2S. So all these possible products of hydrogen, they, because when hydrogen iodide react in this way, H2SO4, sulfur, iodine plus water, and 6 moles of, and if H2SO4, so in this case H2S plus iodine and water are formed. These are the possible uh, reactions of hydrogen iodide with sulfuric acid. So the observations will be purple vapors of iodine, you can say yellow deposits of sulfur, rotten egg smell of hydrogen sulfide, H2S, rotten egg smell, and heat is evolved. Bubbles of heat can be seen. So compound X, next question is compound X and anhydrous group 2 bromide is dissolved in water and titrated against aqueous silver nitrate. Aqueous silver nitrate solution containing 0.250 gram of X requires 33.65 centimeter cube of 0.0500 mole per dm cube silver nitrate for complete reaction. Identify X. XBr2 plus silver nitrate to form silver bromide plus M1XNO3 twice. So we have concentration on volume of silver nitrate. So first calculate moles of silver nitrate is equal to 0.0500 into 33.65 divided by 1000. This is equal to 1.6825 into 10 raised to minus 3. Now moles of so balance the chemical equation. NO3 twice, 2 over here and 2 over here. So the mole ratio is XBr2 ratio silver nitrate 1:2 and 1.6825 into 10 raised to minus 3 ratio X. The mole of XBr2 is equal to 1.6825 into 10 raised power to minus 3 divided by 2. So this is equal to mole of X is equal to 8.4125 into 10 raised power to minus 4. So we have mass of X. So calculate the MR, and this is mole of MR is equal to mass over mole. Mass is 0.250 divided by mole. 8.4125 into 10 raised power to minus 4. This is equal to 297.18. So XBR2 is equal to 297.18 X plus BR2. Bromine mass is 8160 is equal to 297.18. So X plus is equal to 29718 minus 160. This is equal to 297.18 minus 160 is equal to 137. X is to 137, and this is group 2 metal. So if we look at the group 2 metal from the periodic table, it is barium. So AR of barium is 137. So the answer is BaBr2. Question number 3. Alkenes undergo an addition reaction with a 1:1 mixture of carbon monoxide and hydrogen to form aldehydes. Figure 3.1 shows the reaction of propane with 1:1 mixture of carbon monoxide and hydrogen. Define addition reaction. The addition is the reaction in which two or more than two atoms or molecules or compounds added to form one product. Aldehyde A and B are structural isomers. State the type of structural isomerism shown by A and B. CHO. This is 1 2 1 2 3 4. If we write down CH2, this is CH3, CH3 and CH2. This is 2-methyl. So this is chain isomerism. Or you can write down chain isomerism. Name A structure. Name A is the butanol. The complete reaction of propene with 1:1 mixture of carbon monoxide and hydrogen produces A and B only. The product mixtures contain 96% A and 4% B. Calculate the mass of A produced this reaction when 5 into 10 raised to 3 kg of propene is used. Complete reaction of propene with 1:1 mixture of carbon monoxide and hydrogen produces A and B. Only the product mixture contains 96% A, 4% B. C3H6 plus CO plus H2 produces A and B. 1, 2, 3, 4. C4H8O plus C4H8O. This is A, this is B. Okay. This is 96% and this is 4%. This is 5 into 10 raised to 3 kg mole of C3H6 is equal to 5 into 10 raised to 3 kg divided by 42. So mole is calculate the mass of A produced in this reaction when 5 into 10 propene is used. Propene is used 96%. The mole is 5 divided by 42. This is equal to 119.0476 mole. The MR of compound is MR of A is 12 into 4 plus 8 plus 16. This is equal to 48. 48 plus 8 plus 16. This is equal to 72. So moles of N. So if we see 96% and this 72 mR mass of the and mole is so mass is 1190476 into 72. One one nine point 0476 into 72 is equal to 8571. So if 100 is equal to 8571.4, so if 100 contain 96, 8571.4 contain x. So this is 96 into 8571.4 is equal to divided by 100. This is equal to this is equal to 8 to 8.5. So it is approximately equal to 8 to 30 kg. A and B show reactions typical of aliphatic aldehydes. A undergoes a nucleophilic addition reaction with a mixture of HCN and KCN, forming compound C. Complete the diagram to show the mechanism for this reaction. Include charges, dipoles, lone pairs of electrons, and curly arrow. Okay, partial negative, partial positive, and CN. This is CN and C3H7. Table 3.1 shows information about 3 experiments involving B. This is B. Okay. Involving B. This is B. Solution turns from orange to green, so this is acidified. K2 Cr2O7. So this is CHO. COOH, and a silver mirror forms on the sides of the reaction vessel. This is Tolan reagent. B is oxidized by acidified potassium manganate. Complete the equation for this reaction. Use O to represent one atom of oxygen from the oxidizing agent. Sorry, this is missing. So no reaction over here because there is no double bond. No alkenes are there. C4H8O to form CH3, CH3, COOH. Or C4H8O2. Yes. C is a chiral molecule. Circle any chiral centers in the carbon. This is chiral center. When propene reacts with CO and an excess of hydrogen, an alkene and a mixture of alcohols are formed instead. The alcohols are isomers of each other, suggests the molecular formula of the alkene and alcohols that are formed under these conditions. Alkane and mixture of alcohols are formed instead. The alcohols are isomer of each other. Molecular formula of alkene. One thing is missing over here, which is because HCN and KCN forming compound C. So this step is also, you can show this step also. So the carbon monoxide and hydrogen alkane and a mixture of alcohols formed instead. Mixture of alcohol and alkane. So over here two compounds are formed. One is this and this. So if alkane is there, 1 2 3 1 2 3 4 1 2 3 4. C3H8 plus CO and hydrogen to form alkane. C3 propene, sorry, C3H6. This is L1 is alkane, C3H8, and other is alcohol. So that is 3 carbon 1 4, so that is C4H9OH or C4H10O. So molecular formula of alkane is C3H8 and C4H10O. The reaction of ethene C2H4 with 1:1 mixture of carbon monoxide and H2 is shown in equation. Okay. Now, atmospheric pressure, a cobalt based catalyst is used in this reaction. State and explain the effect of using catalyst on this reaction. Catalyst increases the rate of reaction. By providing an alternate reaction pathway of lower activation energy. Explain why the yield of butanol increases when the overall pressure of the reaction mixture is increased. Yield is increased when the overall pressure of the reaction mixture is increased. Equilibrium moves to right hand side as there are